My presentation today, I will explain in a few slides the backscatter processing in IFREMER, and I will give some point of view how we believe, what we believe to do in the near future inside the backscatter working group. This work is done with my colleague. The presentation is made with my colleague Laurent Berger and Cyrille Poncelet.
You gotta click on the presentation to activate it. So just click anywhere.
So from the beginning in IFREMER, we focused in the absolute value of the backscatter processing for many reasons, because we need to compare data, because we have a lot of comparing, so we need to compare data when we have a time series from many compares in IFREMER. For seafloor monitoring, also by comparing in the same area many systems or with the same system but in different surveys, and also to do in the future spectral analysis. So if we have calibrated data, we can do this kind of analysis, and also in maybe in near future a physical model. So the solution to do that is backscatter calibration. For that, we have three methods to calibrate our system in IFREMER. So the first one is we have defined a few years ago a reference area near in the Bay of Brest. So area here. So it's an area with a 20-meter depth. And we, for this reference area, we check it during 5 years for stability. So it's an area used by the hydrographic service for the bathymetry calibration. And we used also for backscatter calibration. We know now it's a stable area, backscatter doesn't move. And to have the reference curves, we use the single beam echo-sounder. We tilted in different angles, and now we have reference curves from 45 kHz to 550 kHz. So we have all frequencies. We did this work for multi-spectral analysis, but we have all multi-beam frequency also to calibrate our multi-beam. So this is the first method. We use a lot. All our ships, they come in this area before compare, and they the mode they want to use them during the campaign, and we can post-process the data and estimate the backscatter correction to have the absolute value. The second way, we use it for low frequency systems. Here, an example that we did a few years ago for the EM304. On board the Thalassa, we used as in the reference area, we use also an EK80 system with 38 kilohertz, and we in flat area, I think here at 800 meter. Homogeneous area, flat area, and we use both systems, the 304 and the EK80, and it's the same measurement here. Going to have the EK80 measurement, the filter model, and here we have the EM304 measurement, and then when we compare both systems, we can estimate PS4 for the EM304. So the 38 kilohertz single beam is fully calibrated with the sphere type. The last method, it concerns the ME70 system. People who don't know, it's officially a multi-beam system, but it has a bathymetric option, and we can calibrate it with a reference single beam, reference sphere target, and we can estimate like the gain on DP here and put it in the multi-beam solar, and we have direct absolute value. And for my point of view, the best multi-beam. Come from fishing. It's a system with in bathymetric option. It's 3 parallel degree opening angles. It have 81 beams, and it's with long pulses, and it's fully calibrated. It's very system. This is it. But we use it a lot for Backscatter. So as I said, this calibration, we are aware it's not an easy task. That's I understand why the word calibration doesn't appear in the top 5 words because it's a heavy task. For example, in time calibration, we need a heavy installation, and it's only feasible for high frequency multi-beam system. For reference area, there is a lot of requirement. So we spend a lot of years in IFREMER to find this runner area. And also we have to control this stability each year to be sure it's still a reference area, and also the time consuming because we have to take measurements for many frequencies for all existing multi-beam systems. For cross calibration, it's we need a lot of heavy installation on board for ships. So, and now in IFREMER, for example, we are not capable to calibrate 20 kilohertz system because we don't have for this kind of system the single beam microsounder, the EK80, 80 kilohertz, and it's low frequency, the EK80, and it's big transducer. There is no system we can test it with it, so we are not able to calibrate this kind of low frequency material. And also for single beam microsounder, we use the EK80 with 7 degree opening angles to calibrate multi-beams, usually with 1 or 0.5 degree. So there is some issue with especially in the area. So there is always many constraints and limits for this kind of method. But what we think we can do, it's possible today. I think from constructor, I think we need today the factory calibration, minimum factory calibration for emission and reception transducer, and also transparency for the all backscatter validation class. So that's, I think, something we can ask for constructor. Also, we need, as explained by Xavier before, we need a logging tool for backscatter correction from this construction. There is some of them, we have this kind of service like Norbit or Volkswagen system, but I think it must be the case of all constructors. from the community, what we can do to calibrate system. I give here an example, a joint project with our colleague from Belgium. For example, the new Belgica will pass in a few months in Galileo here to calibrate the EM240 system, system. They pass in Galileo and we help them to calibrate their systems using our reference curves in this area. We have also a joint project in, next year to make a new reference area in the Belgium, here from the Belgian key white area, maybe Mark, let's say some words you want about that after. So we have a joint project. That doesn't mean that IFREMER we can help people to do that our method, because we have already all BK80 transducer in our service. But I think in this kind of joint project we can create many areas for people, and it will be possible to calibrate at least the high frequency multi-beam system. So for backscatter analysis in IFREMER, generally we have two kind of data from backscatter. So in IFREMER, we don't use a lot the mosaics. We only use it for as to give to users a nice image mosaic by normalization, and we use it sometimes with spatial analysis, or now because we have a lot of frequency in the same area, we can use spectral analysis, but we are focused on signal processing using angular differences. We want to keep this angular difference in our analysis using, because we calculate our system the absolute value, and we correct it for the local slopes to connect the ununified area, and we fit it with a empirical model for our data, and we deepen all our analysis this kind of curve. So the first step when we try to work with the angular response curve, it was how we can extract this kind of curves, how we estimate, which method we have to do. For that, we did a work with Louis Xavier in IFREMER 3 years ago to study which method we have to use to estimate this angular response curves. And I remember when we, after each meeting in our office with Xavier and Luciano and Jean-Marie, our colleagues, they laughing. So mean, median, amplitude, squared amplitude, for people it's stupid to do that, but it seems very useful work, because when we saw the result of the SCP project, the intercommercial project, which the conclusion was the most detailed DS processing step becomes from the extraction of the data at the first steps. So when we see that, we was happy by our work. So and this work is already now in our statistical analysis we use systematic this or recommendation this favorite. So for that, I think it's clear for the community is the need for a standard system chain or to just don't have this kind of problems at this critical stage. So for that, in IFREMER, we believe that we should go to open source system to chain to have a reference algorithm for all community to have this level of knowledge accessible for all the users, and we believe also to reactivate the OpenBSD project. For people who don't know, maybe Mike, you say something. So it's a project from a joint project with the IFREMER and the INH. It started, I think, 2018, but it's inactive since 2019. I think the problem was when Giuseppe left INH, a little bit, yeah. So we started the project. The project was to have this kind of tool chain, open tool chain for all people to have this same standard processing steps for the backscatter. So we believe we can reactivate this kind of project with other colleagues for sure. So, but if we don't stop there. We continue to working in this kind of food chain. So now after the Jean-Marie who developed Sonarscope, he was retired. So we stopped Sonarscope, but we will all Sonarscope methodology will be in the another software with a Python algorithm, and which will be open source for all. We do this in the Globe. It's our software for facility data processing. It's always a free software and open source software also, and we will try to code the main processing of Sonarscope in Python, and it will be open source also. It's like here, but it will be software. And now we have some processing, just the normalization of the backscatter is available in Globe, because the user they need to move to bathymetry and to backscatter at the same time. But we are developing like a Google BST, our Globe software, and we think that this work can contribute for the reference good shape for the community. And also we want to share all this with the group. So for that, I think the first step, we believe a lot in the standard format for the backscatter. Because this is a key for sharing data for between all the community, and it will be, I think, the best way, the solution for the software difference to have a standard format that we are sure that people use exactly the same backscatter values. So there is recently there is a new format for people who work in watercolor data. There is a new format called SonarNet here, CAT4, which is developed with the fishery community, and now all I think Simrad, the new IDSP Simrad is delivered with this kind of the form, standard format, and it's integrate all IDCP, EK8 system, the multi-beam fishery multi-beam system, omni reaction sonars, and it's adapted from all fishery community. So IFREMER we was a major contributor for this format, and recently we add some definition for the multi-beam system also. So we use it now in Globe and Sonarscope. We use this format, but for multi-beam system we are Globe, and contribution are welcome to have like fishery community to have a standard format for the multi-beam standard system. So this is the form is always published, so you can take a look, or if you use our use the blog, you can convert any especially post-based multi-beam system to this format, and there is a lot of tools you can check and display this format. There is a panoply from NASA, the free software, you can check this format to see all fields on it. And we think it's the solution to have the same level at the beginning. The main goal is not to replace professional software or something like that. It's just to have an intermediate format between the raw format of the sonar and softwares. So all softwares, you can have the same beginning of the information. This is the idea when they, the fishery community, there is equation which validated by all the community for each system, and we, if you take any system, all people they have exactly the same level of knowledge. So we will, our colleague Cyrille Poncelet, who is involved in this project, he will also develop the bathymetry extension for this format, and he will share this format in a kit here, and you can contribute. The idea is to that all community contribute for this format to have a standard format for all Here an example from a globe for this format. Now in this in our globe software, we have one system for all solar system. For watercolor or for backscatter or for bathymetry, we have the same system using this standard format. We can here we have an example with watercolor data and bathymetry data. We have here EK80 data and also LDCPs. All these kind of the same form, standard format for all these kind of solar in the same software. I think it's really helpful when in oceanographic vessels we have a lot of systems. So I think it's, to have the same format for all sonar, it's we think for facilitate a lot of things for software. So for the angular response analysis in IFREMER, our choice was to use empirical classification instead of physical model aversion, because a lot of problem, because we think now we don't have a physical model which is available for all sediment types or for all frequency. So we start to do our analysis with empirical model using the GZAP model. So the workflow, we start from a compensated backscatter and calibrated also. We fit our GZAP model and we extract some 4 to 6 parameters from this model using some ground truthing and training a database to classify the seafloor. This is our standard workflow when we analyze the backscatter. So here some examples which always shown by Xavier. Essentially, when in IFREMER we have two main multi-year campaigns, which called IWE and CGFS, and using the ME70 multi-beam sounder, which is calibrated each year with the target sphere, and we use the bathymetry option for that. And we have since 20 years, 30 boxes each year in the Bay of Escape. Before this area is done by the IWE campaign and in the English channel by CGFS campaign, always with the same sheet, with the same so it's fully calibrated to analyze the backscatter. Now, the way that we do that we, as I said before, we don't use the mosaic to analyze the backscatter. We use For our analysis, what we call the beam geometry, we look at 45 degrees each time. Here we have an example, a histogram, to just detect how many sediment types we have in our data. And then when we find the number of our cluster, we segment or cluster our data in this geometry by looking for each angle independently, and then we extract the two curves for each array. This is, and all this processing is fully automatic because we have a lot of data, so we did that with automatic way. We have just to process the bathymetry to connect the simplified array. All the backscatter is fully automatic. And then we, what we do now is to extract this kind of curves. For each curve, with ground, we think we are now have a nice database with this kind of curves, and with ground, we think usually we do that. So we did, with the angular response curve, also we did a lot of azimuth dependence analysis in our area. So it's just by a comparison between the parallel lines in the same area and the cross lines. If we have azimuth dependence, we can see it very easily. But if we work in the mosaic, we can do that kind. This is imaging, and it's just display the mean curves for each lines, parallel lines, and the cross lines. If there is any azimuth dependence, we can see it. We also studied the stability of areas. Here we have an example of the stability of area. It's surveyed from 2008, 2012, and 2014, and we can check the stability of the backscatter using the angular response curve. That way, we prefer this kind of analysis than mosaic. Here, an example of the processing of this is always shown by Xavier. So we have all the boxes from if we compare here, and we have a lot of transit when during the compare and board the ship. They log also the transit from boxes, so we can use it automatically also to have this kind of backscatter clustering. So another thing is few words about the mid-spectral analysis. Recently, we did a lot of work in this in the data press in 4 areas. We did a lot of measurements with the EK80, and from 45 kilohertz, 35 kilohertz to 550 kilohertz. We try to analyze the frequency dependence in this area. This one is published right here, and we 2 years ago we have did the same things, but in another area with 7 sites, different sites. So for the future, also for the multi-frequency now, in this 2 campaign, now we have a new 2040 system on board the ship. So we will log the ME70 at 9 kHz and 2040 in 200 or 300 kHz, and we have also the EM4 system. We can log more than frequency. We can log 3 frequency on board the ship. We do this systematically in this campaign now. We have lines. We will continue to have ground things in all these boxes to have this link between the curves and the seafloor. And for the future also, we will work in the BSWG project as explained by Xavier before, and we start looking for physical modeling with Richard. I think he will explain that. So, thank you. Sorry for this.
No problem. Thank you.